Hello and welcome back to another NeetCode roadmap. And we're going to get into the product of array except self. Another medium question that I'm excited to get into. Excuse me. So we're given an integer array nums, and we want to return an array answer such that answer I is equal to the product of all the elements of nums except nums of I. Okay, I'm trying to wrap my brain around this. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums of I. So we want to be able to, we're given nums, and we create an answer. So if it's position 0, we're doing 2 times 3 times 4 to get 24. If it's position 1, it's 1 times 3 times 4 to get 12. If it's position 3, then we're multiplying 1, 2, and 4, which is 8. If we're going position 3, we're doing 1, 2, and 3, which is 6. And then down here, even when we look at position anywhere except there's 0, it's going to multiply them together, which makes sense because 3 times 3 is negative, or 3 times negative 3 is negative 9, and negative 1 times 1 is negative 1, and negative 1 times negative 9 is positive 9, and we skip the 0 in the middle. We also want to make sure we want to take into account the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. I must write an algorithm that runs linearly without using the division operation. Oh, this is a little puzzling because it's a little puzzle. But what my gut is to do is to, just based on what I know, I want to create a hash map. And I want to iterate through all values except for create an output array in the hash map as they appear in the nums array. Multiply each value in the hash map together except for the one that it's enumerated on. If it's this straightforward, then that's cool, but I don't expect it to be. But this is my gut of what I just know from not knowing anything. Multiply each value in the hash map together except for the one that it's enumerated on. Like the one that it's looping through. We can just say that. Okay, then we multiply each value in the hash map together. Then we plug that multiplied value into the corresponding enumerated spot in the output array. Maybe we don't even need a hash map. But basically, you want to give an output array, create an output array. We already have the input array nums, but we want an output array where we have 1 times the length of nums. So it's just empty. Then given a prefix, the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. I don't really know what this means. The product of any prefix or suffix is guaranteed to fit in a 32-bit integer. I don't know what this means. If you calculate the product multiplication of any continuous sequence of elements at the beginning of or end, the resulting value is guaranteed not to exceed the maximum value that can be stored in a 32-bit integer. Calculate the product of any continuous sequence at the beginning or end. So it can help me choose the appropriate data type for variables that store these products to avoid potential overflows or other issues related to exceeding the limits of the data type. So I can confidently use a 32-bit integer data type like int in Python for calculations without worrying about exceeding data type limits. So what would I use if I wanted to go higher than that big number? So if I need to work with numbers larger than the maximum value of a 32-bit integer, I can use a 64-bit integer data type, which can store much larger values. So in Python, the int can, it actually goes as needed, but I have to specify to use long or long in C and C++ or long if I'm looking at Java. In C#, I look at long for 64-bit data types, and that thing goes long. That thing goes long. They named it right. Can I go to 128? That's big. Wow. Wow. Really? Wow, really? 128 bits? That's huge. What would that be? It's called big integer. That's like big Yoshi. The big integer class in the java.math package. Okay, what does that look like? What's the maximum number? Oh my god! What? That's huge. What is that? What is this number in words? $170 quintillion, 141 quadrillion, 183 trillion, 460 billion, 469 million, 231,731 million, 687,303,715,884,105,728. And can be challenging to read or write in words. That's so awesome. Okay. I wonder if there's any real use case. What would I want to use that? Cryptography. Holy crap. Seriously? Oh my god, it's actually used? UUIDs. Oh, wow. I've seen UUIDs before. in Google Firebase. Or like user IDs. I don't know if it's the same. High precision computing, calculators, advanced math and number theory. That's so sick. I wonder. Oh my god, it's so big. I wonder. $10.24. Okay, this is the last question. Oh my god. Are you serious? Oh, they don't. But it's, you can use arbitrary. Wow. Python's great, but it's slow. That's why it can handle this. Java, you have classes to do it. Boost out multi-precision. Cool, cool, cool. Big integer. All right. Enough of a detour here. So, we've really gone off the rails. So we know the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. So we know it's not going to be huge. I wonder why that's useful here. Why would we want to know that in the context of this? We'll get that question answered later. We can assume the prefix, though, can be 1. And we'll loop through I in the range of the length of nums, because we're just going to go through each instance, each section of the array, and we're going to find the output of I and assign it to the prefix, which is 1. Then what we're going to do is we're going to take the prefix and multiply itself by the nums I. I like it. And then we can create, well, nums I output. What does this do? 1. It puts 1 in every section of output. So then for I in the range of the length of this, we have output I equals prefix 1. And prefix is multiplied by nums I. Oh, I see why it says don't use division, because you can divide it by the num that exists here. So we can create a suffix which equals 1 and go backwards in the range of the length of nums, -1, because we want to account for any index errors. And we have -1 and -1, where we're looking at the output of I times the suffix. And then we create the suffix times the nums of I, and we can return the output. Very simple solution where we're just using 2 loops to go through each section. I don't even know what I'm saying. We use a loop here to go through the range of the length of nums, where we assign output I, which is just an empty array of 1, to the prefix, which is 1. Then we multiply the prefix by nums I. The prefix is 1 because it's like it doesn't exist. It wouldn't change anything to the overall. It wouldn't change anything to the overall product because it's 1. So if this were 2 or 3, or if 1 were 2 or 3 or whatever, then it would change 24 by whatever the number is in this first array value. But because we're assigning this to 1, it's like it doesn't exist, and it becomes possible for it to be 12. If this turns to 1, then then multiplying all the other values becomes 8. If this becomes 1, multiplying all the other values together will be 6. So it's like it doesn't exist. So you're not dropping it. So the exception, instead of skipping it, which you could do like brute force, you can just make it 1. And I like that. So you just loop through all the values like that. And that makes sense. Output I equals prefix. Prefix equals prefix times nums I. And you just loop through and add it to output. Then for suffix, that is everything that occurs, I believe, after. I'm not sure what this does. Output I times suffix. And suffix times nums I. Okay, so the result is stored in a list called output. The code does this by computing prefix and suffix products for each element in the list. So output equals 1. Okay, I figured that out. It fills output with 1s, and this is a list used to store the final result. Prefix equals 1, and this stores the running product of all elements from the beginning of the list to the current index. That makes sense. I was starting to piece that together, actually. Then we want to start a loop that iterates through the indices of the nums list. So this multiplies every value before. And then this multiplies every value after. So then we have I guess right now I don't have the mental formula of how it is visualized. So that's where my confusion is coming from right now. So we can look through each line here. So output equals 1 times length of nums initializes a list of output with the same length as nums and fills it with 1s. This list will be used to store the final result. Then we have prefix equals 1, which stores the running product of the elements from the beginning of the list, up to the current index. So we'll have 1, 2, and say 3, if 3 is the current index. then what we're doing is we're saying output I is equal to the prefix of 1 and prefix of, which is a running product, is multiplied by nums I as we loop through it. And we go to length of nums. Then we loop through from the back to the front, or our current selection, we'll say 3. Our suffix is 1, and then for I in the range of length, nums, for I at the end of nums, we go backwards by 1, and we have output I, which is the end of the output array, times the suffix, which is 1. And we multiply that by nums I, and we can return the output. So it's like it's not like it's like not the same as what I was thinking. It's like we have one thing in selection and we multiply everything there. And then we have the next one in selection, then we multiply everything there, and then we do it from backwards. I think that's what's happening, but I'm not super sure. Suffix times nums I.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve product of array except itself. So this is another problem from the blind 75 list. As you can see, it's over here.
Okay, well, let's do the drawing explanation because I'm trying to wrap my brain around this.
So if we wanted the product of every value in here except the 3, one way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result. Okay. So it would be helpful for us if we want to do that.
What is stopping it from not, what's stopping it from just exiting the loop after the prefix? Like, prefix is this, but we have prefix is this. Oh, prefix becomes the output. Then we multiply the suffix to the prefix, which is already placed in the output array. So then from here, I'm just trying to think, like, how do we know to stop with every value before if it's the prefix?
That for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right, and then put it in a prefix array. And since we're also going to be wanting the product of values after, it would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We'd basically start at the first
linear
position. Okay, this is going to be 1. So if we're adding this value, we're just going to take the previous value and multiply it by 2. So this is going to be 2.
Okay.
Similarly, we're going to take 2, multiply it by 3. We're going to get 6 here. 4, multiply it by 6. We're going to get 24 here.
Oh,
and
what?
For postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4. Here we would get 3 times 4. Here we would get
How is that 24? 2 times 3 times 4. 12 times 2 is 24.
Similarly, we're going to take 2, multiply it by 3. We're going to get 6 here. 4, multiply it by 6. We're going to get 24 here. And for postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4. Here we would get 3 times 4. Here we would get 2 times 12. And then here we just get 1 times 24, which is just going to still be 24. Now for every single value, for example, 1, we would want the prefix of every value before it. Now, since there are no values before it, we can just say, okay, the prefix for that is just going to be a default value of 1 to keep it neutral. And so we'd also want the postfix of every value that comes after it. We can get that in the position to the right of 1. So we'd want to multiply those together. So 1 times 24. So in the output for this, we would get 24. That makes sense because if you multiply all these together, except for this one, we do get 24. And then we just repeat the exact same process for every value. So over here, we'd want the prefix of the values that come before it, and we'd want the postfix of the values that come after it. So 1 times 12 is just going to be 12. That's going to be the output. Again, repeat the same thing for here.
Oh,
prefix is 2.
That's weird.
Postfix is 4. We're going to get 8 as the output. That makes sense. If you take 24, if you take every value in here, multiply
what an
it
interesting
except for 3,
question.
we do get 8. And similarly for this 4, we'd want the prefix 6 and the postfix. There are no, so we just assume that there's a 1 over
That's
here.
like
So
not
6 times
super
1,
intuitive
This would be
to
the
me.
output. So this is a very valid solution. This is a big O of n times solution. We're not using any division operator, but the downside is this is also big O of n memory, but we can actually use this idea because what they tell us is the output array does not count as extra memory. So we actually don't need these prefix and postfix arrays because we can compute these prefixes and postfixes and then store them in our output array, and that is going to end up making things easier for us because we're not going to have to use this extra postfix prefix memory. So what we're going to do is we're going to do 2 passes on our input array nums. First, we're going to start at the beginning and then go all the way to the end, basically computing every single prefix for the input array and then storing the prefix. So for example, the prefix of this is going to be stored over here, right? Because that prefix is needed to compute the result for this position. And so at that point, what we're going to say is every prefix is going to be in the output. Basically, the prefix over here is going to be stored in the second position. The prefix over here is going to be stored here. The prefix from this is going to be stored here. And remember how for the first position, there is no prefix. So we're going to put a default value of 1 over here. And then after that, we're going to do a pass going from the end to the beginning, computing every postfix. So for example, this postfix, and then in the result for this position. And so at that point, what we're going to say is every prefix is going to be in the output. Basically, the prefix over here is going to be stored in the second position. The prefix over here is going to be stored here. The prefix from this is going to be stored here. And remember how for the first position, there is no prefix. So we're going to put a default value of 1 over here. And then after that, we're going to do a pass going from the end to the beginning, computing every postfix. So for example, this postfix, and then in the result, we're already going to have the prefix stored over here. This
so we just multiply it.
The first 2 values is going to be stored over here. So what we're going to do is we're going to take this prefix and multiply it by whatever is in this position. That's what's going to give us the result that we want for this position. So let's start off. So far the prefix that we're going to be at is just going to be the default value of 1. So we're going to put a 1 over here. Then we're going to multiply it by what value comes over here. 1 times 1 is going to stay 1. So we're going to leave our prefix as it is. Now we're going to be at the second position. So what we're going to do is take our prefix, which it basically tells us the prefix up until this point. We're going to take that and then put it in the output. So 1 is going to be here. And then we're going to take the value that we just reached, multiply it by the prefix. So now the prefix is going to be a 2. So now we're going to be at the third position. So what we're going to do is take our prefix up until this point and go ahead and put it in the output. So 2 is going to be placed in the output. Then we're going to take the 3 and then multiply it by 2. That's going to give us a 6 for the prefix so far. So at this point, we're going to take our prefix 6. It tells us the prefix up until
It's weird. I'm not like completely I haven't completely wrapped my brain around it. But
we have run
it's
out
new.
Of room
it's exposing me
so we don't need to store
new
it
stuff.
in the output. So now
So basically what I'm doing, it's like this number times the prefix of it, or this number times the prefix. This number times the prefix. This number times the prefix, which is 1.
postfix. So for example, this postfix, and then in the result, we're already going to have the prefix stored over here. This prefix, right, the first two values is going to be stored over here. So what we're going to do is we're going to take this prefix and multiply it by whatever is in this position. That's what's going to give us the result that we want for this position. So let's start off. So far the prefix that we're going to be at is just going to be the default value of 1. So we're going to put a 1 over here. Then we're going to multiply it by what value comes over here. 1 times 1 is going to stay 1. So we're going to leave our prefix as it is. Now we're going to be at the second position. So what we're going to do is take our prefix, which it basically tells us the prefix up until this point. We're going to take that and then put it in the output. So 1 is going to be here. And then we're going to take the value that we just reached, multiply it by the prefix. So now the prefix is going to be a 2. So now we're going to be at the third position. So the prefix up until this point, we're going to take that and then put it in the output. What value comes over here? 1, so we're going to put a 1 over here. Then we're going to multiply it by what value comes over here. 1 times 1 is going to stay 1, so we're going to leave our prefix as it is. Now we're going to be at the second position. So what we're going to do is take
so the prefix updates for each value, and we're just populating this output array in 2 passes. That's what I'm just trying to. That's just what I'm trying to figure out.
The prefix up until this point, we're going to take that and then put it in the output. So 1 is going to be here, and then we're going to take the value that we just reached, multiply it by the prefix. So now the prefix is going to be a 2. So now we're going to be at the third position. So what we're going to do is take our prefix up until this point and go ahead and put it in the output. So 2 is going to be placed in the output. Then we're going to take the 3 and then multiply it by 2. That's going to give us a 6 for the prefix so far. So at this point, we're going to take our prefix.
The prefix
6, it tells us the prefix up until this point. So we're going to take it, put it in the output. 6 is going to be put in the last position. Then we're going to multiply 4 by 6, which is going to give us 24. But that value 24 is not going to be put anywhere because clearly we have run out of room to put it. So we don't need to store it in the output. So now we've visited every single value from the beginning to the end, computing the prefixes and then putting them in the output array. So now we're going to start at the end and go to the beginning and do the exact same thing, except we're going to be doing postfixes, which are basically starting from the end of the input array and computing the products. Once again, the postfix is initially going to be set to 1. So what we're going to do is take the 1, which tells us the postfix up until this point, basically an empty thing. And that makes
1
sense
times 4
for this value
6.
4, we would want the prefix of it as well as the postfix. But there is no postfix, so that's just going to be a 1. So we can take that 1, multiply it by 6. So 6 is going to stay the same.
The 1 is
so that's going to be the result value for this
position.
position.
When we're in this position, we multiply by 4. 4 will become the postfix.
By the 1 in our postfix. So our postfix is now going to be 4. So we visited this position. Now we're going to be at this second position. So we're going to take our postfix, which tells us the postfix up until this point, and then multiply it by the 2 that's in this position. So 4 times 2 is going to give us an 8 for the output value. Then we can take this value 3, multiply it by our 4, which is going to give us a 12. So now we visited this value. Now we're at the next value 2. So we're going to take our
4 times 3
postfix
becomes
up
the
until
postfix.
This point, multiply it by the 1 that's here. So this is now going to be a 12.
And then
we can
all
also
of this
take
becomes the postfix.
And multiply it by 12, which is going to give us 24, which tells us the postfix up until this point, which is going to be useful for us because we know 24. That if we want to get the product for this position, we're going to need that postfix. So we can take that postfix 24, multiply it by the 1 that's over here. So this is just going to be a 24 now. And, that's the entire result. So we basically did the exact same thing that we did with our prefix and postfix arrays, but in this case, we did it without using the extra memory. And we ended up arriving at the exact same result. So it was linear time complexity, big O of 1 memory complexity. Now let's jump into the code. So the first thing we're going to do is create a result output array. So this technically does not count as extra memory in the context of this problem. I'm just going to give each position an initial value of 1, and we want this to be the length of the input array. In the input array,
this is like what I wrote.
The postfix array will almost the exact same thing. So we're going to start at the end of the input array and then go up until the beginning. And that's how you can do this in Python. And so in this case, the result of I, we're not just going to be simply storing the postfix value, because we know that would end up overwriting in the result whatever the prefix we stored was. What we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results, because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply it by whatever value happens to be in the input array nums. And once that is done, we're actually done with the entire problem. Then we can just return the output array result. So this is pretty much the most efficient way to solve this problem. As you can see,
wow, it's not the
memory
most
complexity, best time complexity.
People getting better
I
at
hope
this.
This was helpful. If it was, please like and subscribe. But
it still beats 80%
a lot, and I'll hopefully see you pretty soon. Thanks for watching.
All right. That's pretty straightforward. Okay.